Good afternoon. My name is Lawrence Mobes, and I am an editor here at Manufacturing Engineering Magazine. I'd like to first welcome everyone to another edition of the SME Media Webinars. So welcome. We're glad you're here. Our topic today is sortation technology and upcycling. Today's presentation is sponsored by Aluminum Transportation Group. The Aluminum Transportation Group helps communicate the benefits of aluminum adoption in automotive applications through research, training programs, events, and related outreach activities. Together with their member companies, they provide technical resources highlighting why automakers, suppliers, government stakeholders, and consumers should choose aluminum. Our presenters are Gary Gallo, Colin Whitman, and Bernardo Bolnes. Gary Gallo is the Senior Manager of End-to-Life Recycling Technology at Novelis, specializing in emerging technologies for aluminum alloy identification and segregation. He works to enhance aluminum recycling and foster partnerships for circular recycling. Now, before I turn things over to Gary to introduce the rest of his team, I'd like to outline how the webinar will proceed. On the right side of the screen, you'll see a question and answer box. If at any time during the presentation you'd like to ask a question, please type it into this box and send it along. These questions will be answered at the end of the presentation. Should you experience any difficulty during the webinar, such as a blank screen or lack of sound, please use this Q&A box to alert us, and we'll respond individually in writing with a suggested fix. Also, this presentation is being recorded and will be available to view later today. You may then watch the recorded version of the webinar at a time and place when you have more bandwidth. You may also watch this webinar as many times as you wish to catch details you might have missed or for any other reason. All you need to do is sign in again using the same credentials that you used to join us now. If you wish, you may share these credentials with colleagues who might benefit from learning more about this topic. Now, if everyone's ready, I'd like to turn the microphone over to Gary, Colin, and Bernardo. Gary, the stage is yours.
Thanks, Lawrence. On behalf of the Aluminum Association and the Association's Automotive Transportation Group, or ATG, it's a pleasure to welcome you to this webinar. I have the privilege of serving as the chair of the Recycling Committee for the ATG, and in this capacity will moderate today's webinar. I'll be joined today by two industry colleagues, Colin Whitman, Director of Scrap Procurement for North American Hydro, and Bernardo Bolnes, Director of Raw Materials for Aluminum Dynamics, or ADI. As Lawrence referenced, this is the second webinar we've done recently on the topic of sustainability. If you missed the first, you'll see a QR code at the end of the presentation that will link you to these webinars, as well as additional information on the Aluminum Association, the ATG, and Drive Aluminum. Now, as of this morning, we had almost 250 people signed up for today's presentation. Looking at the registrants, we are pleased to note a broad base of industry and professional backgrounds. Our goal is to provide everyone with some new insights into the topic. Based on your feedback, today's session might serve as a launching point for a follow-up webinar, taking a deeper dive into the various segregation technology solutions. Today, Colin, Bernardo, and I will be discussing the technology roadmaps that each of our companies are pursuing. Before we jump into those presentations, let's take a look into the sponsors of today's webinar. The Aluminum Association represents the U.S. aluminum industry and is based just outside Washington, D.C. In recent years, the industry has seen tremendous investment and growth, creating both new opportunities and some challenges. Today's webinar is presented by the Association's Aluminum Transportation Group. The goal of the ATG is to highlight the benefits of aluminum in transportation, including its environmental friendliness, safety, and cost effectiveness. Now, given the diverse backgrounds of our audience, we thought it would be good to spend a few minutes outlining the reasons behind why scrap segregation technology was chosen as the topic for this webinar. This map outlines the significant growth in global aluminum production. Investments are increasing the demand for scrap, coupled with the desire to reduce greenhouse gas emissions by increasing the use of recycling materials to drive recycled content. Now, in this map, you'll see that the announced capacity of increases in secondary aluminum production total 6.5 million tons ex-China. Of that 6.5 million tons, about 1.5 million of those are here in North America. But China's increased capacity is nearly 15 million tons. Now, for perspective, the 6.5 million tons is about a 30% increase over 2023 levels, while China's represent a 1.6 times increase in their 2023 production estimates. Now, when we refer to a secondary aluminum production, we are talking about aluminum that is produced in some part using scrap. Primary aluminum is produced using bauxite ore and is not represented here. The bottom line is that this represents a significant increase in global demand for scrap. Where's all this scrap coming from? Well, for those not necessarily familiar with traditional sources of aluminum scrap, here are some pictures of the types of materials our industry regularly recycles. Aluminum is infinitely recyclable, highly recycled, and nearly 75% of all aluminum is still in use today. Aluminum products and the resulting scrap are generally broken into two categories: wrought and cast. Cast products like wheels, engine blocks, and transmission housings are made from aluminum alloys generally higher in silicon, having silicon levels from a few percentage points to well over 10%. Wrought products consist of things like extrusion and sheet used for beverage cans, auto, and aircraft. Silicon levels for these products is generally lower than 1.5%. Now, most of the scrap that you see here, such as wheels and UBCs or used beverage cans, have well-established scrap recycling ecosystems that typically remelt and recycle them back into sheet or cast and keep that in the same alloy family of cast or wrought. Wrought scrap can be used to make cast products, but cast can generally not be used to make wrought products due to the high silicon levels. Doing so would require the use of significant amounts of primary aluminum. Now, once wrought is recycled into a cast product, it cannot be recycled back into sheet or extrusion. We refer to this process as downcycling. But let's focus for a minute on the two scrap grades that are often downcycled and the focus of our attention today. If you look carefully at the photo on the left, you will see cast, extrusion, and sheet aluminum in the scrap product refers to as twitch. Almost all twitch is currently downcycled into cast products, and most of it is exported. Once downcycled into cast, it can't be used for new wrought products. For this reason, upcycling or harvesting the wrought from twitch has become a major focus of the aluminum industry. Developing the technology to enable this segregation is the first step and the subject of this webinar. On the right, recycling new production automotive sheet, consisting here of 5 and 6,000 series alloys, requires the use of primary aluminum to bring the scrap to an on-grade condition. As an industry, we want to use primary aluminum for its highest and best use, the making of new aluminum, and not correcting imperfections in recycling. Developing production scale segregation technology for mixed new production scrap, whether sheet, extrusion, or cast, is also a major focus of the industry and something we'll talk about today. When looking at the mixed new production scrap, you might ask, well, why not just segregate it at the point of generation? There's a variety of reasons, from capital and space limitations to production flexibility requirements. Regardless of the reason, many manufacturers are not able to optimize the scrap streams, and segregation technology can offer an alternative. So let's take a quick look at exactly what is this thing called twitch. We've all likely driven past a scrap recycler and seen something like this image. Today's scrap industry starts the recycling process for things like cars, appliances, by shredding them into fist-sized pieces of metal. But cars and appliances are not the only things that get shredded. Think buses, machines, bikes, gas grills. If it consists of multi-materials and multiple metals. Shredding is what begins the recycling process. Once shredded, steel is removed by magnetic separation. Additional downstream equipment removes the non-metallics, leaving a collection of non-ferrous scrap like copper, manganese, magnesium, stainless, and aluminum, referred collectively as Zorba. Zorba is further processed, leaving just the aluminum product called twitch, mixed cast and wrought aluminum scrap. Twitch is about 60% cast and 40% wrought, and the North American market for twitch is estimated to be about 3 million tons. The wrought in most twitch is downcycled into cast products like A380 or ADC12, and when it is, the wrought is lost into cast forever. For this reason, evolving the twitch market to reclaim the wrought fraction to be recycled into new wrought products has become an important need to address the scrap opportunities we talked about earlier. Since the twitch market is both well-developed and global, evolving it to segregate cast and wrought fractions will take some time, but this process has already started to gain traction, and we'll talk about that in the balance of the seminar. The format of today's webinar will be to describe how Novelis, Hydro, and ADI are approaching the need for additional scrap via alloy segregation technologies that will benefit both our individual companies and the entire aluminum industry. With that, let me switch gears and move from your moderator into my role describing how Novelis is approaching the world of segregation. Now, for those of you who are not familiar with Novelis, we are the world's largest flat roll aluminum producer, supplying the automotive, aerospace, beverage packaging, and specialty markets. We're also the world's largest recycler of scrap aluminum, with our automotive customers at Ford, Jaguar Land Rover, and other OEMs. We operate and support the largest closed-loop recycling programs in the global auto industry. Our experience as the leading provider to Ford's F-150 program, coupled with our sustainability objectives, has driven our engagement with alloy segregation technology development. It's clear to us that not every OEM has the ability to segregate their scrap, and that providing this solution is critical to our mutual sustainability goals and those of the aluminum industry more broadly. In this slide, you can see that aluminum scrap is generated both during the manufacturing in the small blue circle and in the use phase in the green circle. Mixed scrap is generated by both auto stamping as well as end of life. Finding segregation solutions to provide both of these needs has been something we've been working on for some time. Our approach to addressing this opportunity has been to first work with segregation technology manufacturers to develop their equipment to produce a scrap product that meets our specifications and what we believe will also be needed by other aluminum producers. Most notably in this space has been the strategic equity investment that Novelis made in Sortation Technologies in 2022. More recently, we've been working with and working closely with Steiner and other segregation technology providers to drive development. Why multiple partners? Novelis believes that the market demand for segregated scrap, especially wrought from twitch, will require solutions to satisfy multiple solutions to satisfy the total market demand. Novelis is not simply seeking a solution for us, but rather a solution for the entire aluminum industry. In this way, we're not specifically looking to own and operate equipment, rather working with the existing equipment vendors to develop the technology capable of making the segregated product needed by the industry. Our goal is to enable a more rapid expansion of the market. Existing scrap processors can use the equipment provider of their choice, and Novelis will provide purchase orders for the segregated scrap, creating a demand pull that can benefit many and create the needed market change. Now, we're also working within the Aluminum Association and ATG to gather industry support. working with the scrap industry trade group REMA, formerly known as ISRI, to create new industry specs and encouraging secondary cast producers to consume the segregated cast fraction. Recalling that Twitch is exported, our hope is that by creating a market for segregated wrought scrap, we will help to onshore Twitch to the US. We believe that while this market transformation will take some time to fully develop, the early signs of adoption are clear. Now, Novella sees a three-phase approach to alloy segregation technology and market development. All three of these phases rely on the use of multiple sensor technologies, including X-ray transmission, X-ray fluorescence, optical AI recognition, and laser-induced breakdown spectroscopy, or LIBS. When applied to the scrap processing and segregation of scrap, XRT and XRF use X-rays to identify metallurgical composition or characteristics in different ways. Optical AI, on the other hand, does not look to define metallurgical composition, but rather uses imaging and AI to identify a piece of scrap as either being cast, extrusion, or sheet. Notably, Sortera has deployed the use of optical AI to effectively segregate cast and wrought and is currently providing a wrought product that meets our specifications. Steinert is rapidly working to forward the use of XRT to do the same, and their results have been positive. Interestingly, many technology providers are bundling multiple sensors into one box to achieve higher levels of segregation with fewer passes. On the left, you can see the names of some of these equipment vendors. In phase one, optical AI and XRT are applied to create a cast wrought split. We believe this is a critical first step to understanding the alloy composition of wrought twitch, and then determining what additional segregation steps are needed to most effectively upcycle wrought into alloy families. In phase one, wrought twitch can be used into several common alloys without the need for further segregation. In phase two, XRF, XRT, and LIBS can be used to create alloy family groups, which facilitates greater circularity and reduces the amount of prime needed to make new aluminum. In phase three, LIBS will likely be the preferred solution to get alloy level segregation and achieve true alloy circularity. One of the early challenges in segregation technology is the binary ejection limitation. Sortera has addressed this with a multi-sensor 8-out sorting system, and Steinert and others have seen similar successes in their LIBS sortation applications. Regardless of the sensor selected, three common challenges are currently being aggressively addressed to improve alloy segregation in throughput. Piece size, spacing, and metal cleaning or polishing are all enablers to better segregation. By continuing to work with technology partners, scrap recyclers, and industry trade groups, we remain positive that the advances being made by these solutions providers will help advance the aluminum industry into the next level of alloy segregation, carbon reduction, and increased recycled content. And with that, let me pass it over to Colin.
Thank you, Gary. As Gary mentioned, my name is Colin Whitman. I'm the head of procurement for Hydro North America. Just a quick introduction to Hydro. We're one of the leading aluminum and renewable energy companies, and we build business and partnerships for a more sustainable future. We currently have 33,000 employees in more than 140 locations and 40 countries. The North America group I'm a part of is responsible for procurement for our 3 billet cast houses in North America. As Gary mentioned in his introduction, there's a large number of these capacity increases from aluminum producers that we're seeing here in the US as well as the rest of the world. Along with the increase in aluminum production in the US, we're also seeing strong initiatives to cut our CO2 emissions in the upcoming years. The one thing both of the increased aluminum production and the lower CO2 footprints have in common is that they're both going to require an increase in scrap consumption, particularly post-consumer scrap. So when we go out to procure scrap, and Gary touched on this a little bit, we look at three different streams of aluminum. There's primary aluminum, which is made from turning bauxite into alumina, which in turn is turned into aluminum. There's pre-consumed scrap, which is produced at the industrial or manufacturing facilities. And then there's post-consumed scrap. This scrap is end-of-life scrap or end-use scrap. This is the scrap that has lived a life, and once its usage is complete, it's recycled, such as an automobile or a used beverage can. The issues with post-consumer scrap is that the composition is made up of a mixed bag of alloys. An easy example is the aluminum can. Its body is made up of a 3000 series aluminum alloy, while the lid of the can is a 5000 series alloy. So we have two alloys making one product. This is where sortation comes in. Sortation technology comes into play. In order to meet the increased demand in these cast houses and cut our CO2 emissions, we need to get these end-of-life scrap streams back into their original alloy group. So what does increase circularity in aluminum? How do we get these mixed end-of-life scrap streams back to a form and composition that's usable for a producer such as Hydro, or a slab producer such as Novelis, or even a secondary foundry alloy producer? The best illustration comes in the form of the automobile. A car is made up of various metals: steel, aluminum, copper, nickel, magnesium, and other non-metallics or organics. Recycled cars are usually sent to an auto shredder, which I think most of us have seen, these large shredders that sit in scrap yards where the car goes in and it's shredded and downsized. Usually these shredders have various outputs where they run across magnets, pulleys, screens, and eddy currents. From these shredders, these large ferrous shredders, we typically get three outputs: shredded steel, Zorba, and fluff. With the largest metallic content in a car typically being steel, these auto shredders were set up to extract the steel and send it back to the steel mills. Zorba was typically exported, and the fluff organics were sent to a landfill. Since the focus of our conversation today is aluminum, we want to focus on this Zorba output produced by the shredder. So Zorba contains non-ferrous metals that are present in a car. It's going to be a mix of aluminum, copper, brass, stainless steel, and other non-ferrous grades. So to further separate Zorba into individual non-ferrous fractions, we need to size the material again in a smaller shredder, run across another set of magnets and screens. From here, Gary touched on this, we introduced the Zorba to an X-ray system where we can separate red metals, nickel, and aluminum into their different buckets. The aluminum fraction that's now present is what's called twitch. So twitch is a mix of aluminum castings, which come from engine blocks or transmissions, and wrought alloy. This is the aluminum sheet and extrusions from body panels and bumpers. The cast fraction contains large amounts of alloyed silicon, copper, and zinc, which is not ideal to come back into the production for aluminum sheet or extrusion ingot. Through further X-ray sortation, we can separate twitch into independent cast and wrought packages. The final step with this wrought, to make this wrought package usable for the original producer, is lib sortation. So lib sortation, laser-induced breakdown spectroscopy, this technology allows us to sort the wrought scrap into its exact alloy compositions. So at Hydro, we developed AluSort along with Padnos, who is a leading scrap recycler in the state of Michigan. This is a JV between our two companies. At AluSort, we're deploying proprietary Hydro-developed LIBS technology to sort scrap by alloy at scale. Our high sort equipment is the result of over a decade of technology development work by Hydro. And at AluSort, we can take various grades of mixed end-of-life scraps, such as twitch, MLC, mixed sheet aluminum, and sort them back into their exact alloy composition. Since operations commenced in October of last year, we've successfully sorted material at AluSort, and it's been used in a number of sheet and extrusion ingot mills across the U.S. And it's a little bit busy, but here's an example of a single pass through our high sort LIBS technology. The LIBS was programmed to eject 6,000 series aluminum. When a sample from the ejects was analyzed, you can see this sample has a lower silicon, iron, copper, and zinc content, and this allows the 6,000 series eject to be used in the production of extrusion billet. The second fraction, or the drops, has a higher silicon, iron, and copper composition. This composition is very attractive for producers of DIN 226 or A380 production. And these are the casting alloys that make up engine blocks and transmissions in a car. So now I'm going to come back to one of the reasons why we're sorting this post-consumer scrap. Hydro is committed to cut our total carbon emissions by 30% by 2030. So in order to do this, we need to increase our usage of post-consumer scrap through sortation. This is vital to the improvement in our carbon footprint. The more post-consumer scrap that we're able to use, the lower our carbon footprint becomes. In order to use more post-consumer scrap, at Hydro, we're developing what we call RFAs, or recycling-friendly alloys. We have extrusion alloys that are made from 75% post-consumer to recycled material. These alloys were developed with the same mechanical properties as before, while allowing slightly higher tolerance within the minor element profiles. This slight change in alloy composition is allowing us to utilize more post-consumer scrap in our billet production, and this post-consumer scrap has been made available through our sortation technology. And through this continued advancement in sortation of the mixed post-consumer grades and continued progress in the RFA alloy development, we're moving forward towards our goals of reducing our carbon footprint. So thank you all for letting me be a part of the presentation today. I'm going to now hand it over to Bernardo, who's the Director of Raw Materials for Aluminum Dynamics.
Good day, everybody. So what I'm going to do today with you is basically share the experience that we have had through our own scrap management company on the segregation process here at one of the facilities in Fort Wayne, Indiana. I have been with the project for 6 years now. I started in this venture when it was Brady Industries, and I traveled the journey of turning from Brady Industries to Unity Aluminum, and then through the joint venture with Steel Dynamics to come up with the Aluminum Dynamics project. So for people that are not familiar with the project, we're the first aluminum rolling mill in North America in 50 years. It's going to be located in, or it is located in Columbus, Mississippi. And several reasons why it was located there. And this is a reflection of Steel Dynamics' commitment with sustainability, is that we are going to be using the Tennessee Valley Authority electricity sources in order to power the mill. So the mill is going to have a capacity of 650,000 metric tons of finished goods. which require an input of 900,000 metric tons of rolling slab. Our commitment in order to make this mill sustainable is to have an average, or we're aiming to have an average of recycled content, and we are very transparent about how we calculate recycled content, which includes, in our case, the run-around scrap of around 70 to 72%. A couple of comments about that is the first one is that we're going to have 2 satellite plants that are going to be fully dedicated to the recycling of UBCs. One of them is going to be in Arizona, which is being laid out as we speak. And the other one is going to be located in San Luis Potosí in Mexico. And we put them there, we're building them there, because that's where the scrap is available. Scrap market in the West Coast in Mexico is not or hasn't been as generously tapped as we expect. So that's where the search is going to come. I saw an interesting comment about the recyclability of UBCs, and there's a limitation. While we have done some testing in order to separate the 5,000 from the 3,000 out of a can, it's really not economically feasible because the spreads are kind of tight, I'm going to say. And every time that you use a segregation machine to separate scrap, it costs money. So that's one of the situations that we're facing on during the journey that we're venturing. So those 2 plants are going to have a very high recycled content, and which is, as I said, limited by the combination of the 5,000 and 3,000 series. In the case of the rest of the product mix that we're going to be making, which is going to be focused to the automotive industry and the common alloy world, we're going to aim to have a scrap or a recycled content averaging about 60%. So 40% of the raw materials that we're going to be using is going to be P1020. About 29% of the raw materials that we're going to be charging into our melters is going to be run-around scrap, and we're going to be out in the market with the help of OMNI for 31% of the raw materials. So having said that, when we're running at full capacity, we're going to need 17,000 metric tons of external scrap that we're going to be trying to get in the market. And I can tell you that the volume of scrap available in the what we know as the scrap trading world currently is not unlimited. So we're going to be competing with everybody on metal units in order to find the most compatible pieces of metal that with our product. So basically, what we have been experimenting, and is the same as Gary mentioned, and I'm going to be very honest as well. The efforts that OMNI is doing. OMNI is a company that is dedicated to sell scrap. So there's a commercial for OMNI as well. And basically what they're developing is different avenues in order to find what segregation technology fits which material. So they have done trials at Sortation. Of course, we have done trials as Steinert in Germany very successfully. And we installed a purchase TOMRA machine here in Fort Wayne. We have been able to run that machine at what was the promised capacity. This is going to be a commercial for TOMRA, and with successful results for 3 different materials. So I'm just going to skip a little on this description, and this is basically what the TOMRA machine does. It receives the material, it chemically analyzes, and then it physically separates it. So one of the, I'm going to say, advantages of limitations of TOMRA is that you get 2 off streams out of it. So we have been trying to separate 3 different products. The first one is low copper scrap from the mills. That is a combination of 3,000, 5,000, and 6,000. So when you select the separation criteria to be the high mag content out of 5,000, you can separate in one of the stream 5,000, and then you get a mix of 3,000 and 6,000 on the other one. So you have to run the mixed pile again through the tomra machine, and then you separate the two different alloy families very efficiently. The second product that we have been running, which has been very successful as well, is Twitch. And we are very interested on Twitch because, of course, the mill is going to be requiring everything related to the 6000 family series. And we own, as Aluminum Dynamics, or as the Aluminum Dynamics family, we own a secondary aluminum plant here in Fort Wayne called Superior Aluminum, which is very interested on getting all the high silicon cast alloys out of the Twitch. And the third product that we're separating is a mixed stamp coming from an automotive plant based on, the samples that we have been running at industrial level, I'm going to say, come from a plant based out of the state of Indiana. And basically with the same, I'm going to say similar results on the separation process. So this is one of the things that Aluminum Dynamics is trying to make different. We want to be, as I said, transparent. And if you want to come and see how the tomra machine works, I extend an open invitation for you to come and take a look. So the way that we have been running just to give you some numbers, is that the machine can run at about 6 metric tons per hour with any of the three products that we're using, with about, depending on the input, I'm going to say an average of low 90% separation efficiency. So as I said, some of the time you're going to end up with a mixed file that then you're going to have to rerun. But the separation on the material that you are using as your criteria for separation, it's very, very high. So you can see what we enter. I'm not going to say that the scrap industry is the most glamorous part of the aluminum running or extrusion industry, but it's where the money is made. This is where the metal margins make a difference. And we get very, very clean material. So with that, as I said, I'm extending an invitation for you to come and take a look at what Omni is doing. And of course, commercial for Aluminum Dynamics LLC, go to our website and see what we're doing in Columbus. We started casting 2 weeks ago on January 12th, and we are just a few weeks away from commissioning the hot mill. So here it is. Thank you.
Awesome. Thanks, Bernardo. Colin, appreciate it. So we have a good 15 minutes here for Q&A, and would like to open that up. We've got a couple of questions that have already come in. Thank you very much. And I think what we're going to do is start with a bit of a roundtable with Bernardo, Colin, and myself to address a couple of questions that I think might be good for us to get individual perspectives on. So the first one, we've heard a lot about different sortation methods and technologies being used and deployed. Are there still technical challenges to overcome? Colin, why don't I start that with you, and we'll go to Bernardo, and I'll wrap it up.
Yeah, thank you, Gary. Yeah, I mean, we've come a long way with sortation technology over the last 5 years. I think we're going to be working through a small technical challenge as we continue to grow these facilities and kind of learn from some of the setup flaws maybe we have in the beginning. We always have to remember what we're processing is end-of-life scrap. The scrap is never black and white. There's a slight variance in the scrap from every load that hits our doors in terms of composition and form. And the scrap we're getting today, it's not going to be the exact same scrap we're getting in 5 to 10 years from now. So we will continue to develop technology and improve as we continue to go through the sortation process.
Bernardo, what's your thought?
So definitely there are several technical challenges. The first one, of course, is the consistency, just as Colin mentioned. The second one is I'm going to be very candid about this, particularly on the actual technologies available currently. So I'm going to say that the chemical analysis is not the challenging part of an efficient segregation, but the actual physical separation. And there are several, I'm going to say, approaches that the different companies have taken in order to improve the physical separations. So there are air knives, there are pushers, there are paddles that do it, and different ways in order to ensure that the physical part of it is done. One of the challenges that we have been facing on our own in-house cast house segregation system is that we, as I said, don't want to put too much money on the actual scrap. So, for instance, in the TOMRA machines, if instead of using or trying to separate big pieces coming from the stamping plant, we would shred it and then pass it through a TOMRA, we would have probably a more efficient separation. However, shredding it costs money and reduces the metal margin. So we're trying to find a balance in order to make this efficient and cheap.
I would echo both of your comments, and I would add Bernardo onto that. Clearly, one of the things that we have seen, as I mentioned in my presentation, piece spacing and piece size are certainly critical to sensor technology's ability to read a piece and as you say, eventually do the ejection on that. The scrap industry already does a really good job in sizing scrap, but what we're talking about here is something that's relatively new, and we certainly know that the more uniform a piece size is, the more likely it is to be effectively sorted through the entire system. The second question we can maybe tackle for the group here. Can you comment on how you see the deployment of these different sortation technologies happening over the next 1 to 3 or 5 years? What factors could affect the rate of deployment? We'll go backwards on that one. Bernardo, do you want to take a shot at that one first?
Yes, absolutely. And the first one is going to be the actual physical separation of the material that has been chemically validated by the analytic. And one of the you pointed it very well, Gary. The once that you have selected the piece spacing in order to have an accurate reading, you need to come out with a way to physically separate it and then make it at a rate that is going to be productive enough to satisfy your needs. So, I mean, just doing some quick math in some conversation about with our research and development team is when they presented the first machine. I mean, it was relatively reliable on the separation. But in order to meet the supply for this particular mixed stamp scrap that we were getting from this automotive supplier, we would need to have 24 machines like this running 30 days per month just to meet the volume. So that's key. The actual physical segregation is key.
Yeah. Colin, what are your thoughts?
Yeah, so over the next 5 years, we're definitely going to see more sortation technology come into the market. I think you see new players open up facilities, as well as the existing players open new facilities and expand on the facilities already in place. There's still a lot of mixed aluminum, Twitch Zorba, mixed low copper clip being exported, and one of the reasons, in my opinion, is there's not enough capacity to process it here in the U.S. If we want to keep more aluminum in the U.S., we need to meet this increased production demand, we need more sortation capacity. As to the factors that I feel that could affect the rate of deployment for this, I think there's a couple. The first is the drive to be carbon neutral. To get to net zero carbon, we need more PCS, and to utilize more PCS, we need more sortation. The second is driven by consumer demand. This new age consumer, they want to know where their products come from. They want to know that they're sustainably and responsibly sourced, and the most sustainable product is something that's recycled. And as you mentioned, Gary, aluminum's infinitely recyclable. And I think the last point, Gary, you showed this on one of your slides, is there's more aluminum production coming. Therefore, there's a greater demand for aluminum scrap. And in order to make the scrap usable, we need sortation. So the market is demanding more post-consumer scrap, and therefore it's demanding more sortation.
Mm-hmm. Yeah, totally agree on both counts. I think the other that I would throw out as a market driver to this discussion is the fact that the consuming mills ultimately need to put POs in the market to pull the scrap through the market. I think the scrap industry has a long history of deploying solutions to segregation challenges when in fact there's an economic driver to do that. So I think as the market begins to recognize the value of segregated scrap, particularly in the form of twitch, and puts POs in the market, that's going to drive the scrap industry to make the capital investments that are needed to get to that point. And I think I reflect back on the approach that Novelis is taking. We've had a wonderful relationship with Sortera, and in the same way recognize that the size of that market is so huge that in order to achieve significant changes to it, we're going to need all the technology providers that we've talked about, like Sortera, Redwave, Binder, Tomra, to come into the market with technology solutions and make them available to the scrap industry. Awesome. So a couple other questions. I think one question from the chat that came out was, kind of the amount of wrought twitch that is being exported today. I can take a stab at that one. I think what we've seen is that there's not exactly clarity in terms of the material that's exported today in terms of volume. We estimate that there's maybe 3 million tons generated. About 30% or so of that perhaps is consumed domestically. The balance is exported. So it's obviously a significant number in terms of the total export of twitch, and for that reason, back to our prior discussion about the volume of scrap that's in the market and the change that needs to occur is going to require lots of participation by equipment providers and scrap industry providers in order for us to move that needle. Let's see. Another question mentioned. It was mentioned that the existing twitch market needs to evolve in order to enable cast and wrought segregation. What needs to happen to facilitate that change? I think that's kind of directed my way based on the presentation. What needs to happen in order to facilitate the change? I think we've talked about that a little bit. I see from my perspective, 4 things. One, the continued advancement of the technology to be able to get to production scale segregation in ways that meets the consuming mills and the scrap processors need to make a profit on segregating that material. We talked about the need to issue purchase orders to pull that metal through the market, and developing industry adoption. This is something that's not currently being done today at scale. So, whether it's a wrought producer, a sheet producer, an extrusion producer, a secondary producer, we need those market participants to come in and play in a market that currently doesn't exist in a significant way. And I think if we have the three of those drivers together, we can begin to see that change. And Colin, Bernardo, let me throw that back to you. Anything else in terms of what you think needs to happen to facilitate the change in the market?
No, actually, I just wanted to share with the group an interesting anecdote that I faced last year in a symposium that I went in London. There was a presentation by a non-government organization, and they were saying or trying to solve the carbon footprint in the aluminum industry conundrum. And basically they say, well, what the aluminum industry needs to do in order to reduce their carbon footprint is to increase the amount of scrap that they used. And I was scratching my head like, oh, well, you know what, we didn't think about that. So it is challenging. And you know what, one of the things that we're going to be facing, and I'm going to make a prediction here, because of the limited availability of usable scrap, particularly with all the expansions that are coming, the spread between scrap, which is basically recycled content, and low carbon aluminum is going to be reduced. So in a couple of years, probably, the decision on the customer is going to be what kind of green label they're going to be choosing, either low carbon aluminum or high recycled content. And that's what we're going to be facing as well as the commercial entities that we are.
I agree with both of you. Gary, to your point, we need to have everyone active in this Twitch market. The SFAs, the billet producers, the slab cast house, because Twitch is comprised of aluminum scrap that we all want back. When we're in a short scrap market, the SFA homes want the cast back. Me being from the billet side, we want the extrusions, and you both on the rolling side want the wrought. So I think we just need, as you mentioned, more active participation from all parties involved, because Twitch has always defaulted to a secondary smelter because of its chemistry.
Yep, yeah, good point. So I'm looking at time here. We've got 2 minutes left. I know Lawrence has got the one last slide to put up. So let me throw a quick question out here that I think we can tackle pretty quickly as a group. Is the technology you're encouraging or developing created exclusively for your use? Bernardo, I'll throw that one to you, and I'll finish it up after Colin.
Well, not exactly for us, because as I mentioned, one of the applications of an efficient segregation of Twitch particularly is that the cast can be used by the secondary industry. And I've seen a lot of, on the chat, lots of questions about the Twitch export. And the biggest limitation that we have is that the secondary aluminum industry in the States does not have enough capacity to deal with that. So I think in the Aluminum Association, there has been conversation about a ban on scrap exports, but we need to be careful not to make it a blanket ban, but be selective on what we can use and we can process at an effective and efficient rate.
Yep. Right.
So,
Colin, what are your thoughts?
Gary, the technology that Hydro's developed, the high sort technology, is specific for us. However, the segregated scrap streams that we're producing, we market those to the entire aluminum market, from the slab cast house all the way to the secondaries.
Awesome. Thanks. And quickly, I'll add here, because I see Lawrence is back, and I think that means the hook is about to come out. Novelis is definitely not looking to patent this exclusively for our use. In fact, just the opposite. We want to develop the market, encourage the market, and enable the market to make this move that we think is so important for the aluminum industry as well. So thank you everybody for your participation. And Lawrence, I'll turn it back to you with my thanks to Colin and Bernardo for theirs.
Thank you very much. I'd like to thank you guys, of course. I'd like to thank all the members of our audience for your presence here today. And please remember that you can revisit this webinar anytime you wish. As today's webinar has shown, the sortation technology you choose for upcycling or really for any purpose may just make the difference between success and failure. And thank you to our presenters, Gary, Colin, and Bernardo. You may get more information or contact them directly through novellis.com, hedro.com, and aluminumdynamicsllc.com, respectively. And remember, SME and SME Media can help you keep abreast of all the latest developments in advanced manufacturing systems and really just about anything that has an effect on the world of manufacturing. You may check out our podcast at advancedmanufacturing.com or advancedmanufacturingnow.com, rather, to listen to a wide variety of manufacturing professionals discuss the challenges, opportunities, and factors impacting manufacturing today. And don't forget to keep an eye out for breaking news and coverage of the latest technology and strategies for manufacturing at advancedmanufacturing.org. Thank you for joining us on this SME Media webinar. We hope that you found it useful and informative, and we hope that you will come back and join us for future webinars. Thank you.